Today we're going to be talking about right triangle trigonometry. We have 6 trig ratios, and it's important to know how they are formed, where they come from. Let's examine this right triangle. Okay. In this right triangle, if this is my angle that we're focusing on, I'm going to call it theta. There is also an angle here and an angle here, but this is the angle that I'm talking about. With respect to this angle, we have an opposite side, and the opposite side is always opposite the angle. Okay, and then we have the 2 rays that form theta. One is the adjacent side, and one is the hypotenuse. So the hypotenuse and the adjacent side always form your theta. Opposite is the other one. Okay, I'm taking the moment to say all of this because if you don't grasp that now, it's going to be hard for you throughout this whole unit. All right, so opposite is away from your theta. The opposite side is not forming your theta. Okay, the other 2 sides are. Okay, all right, so the ratios, opposite over adjacent, hypotenuse over opposite, adjacent over hypotenuse, those are the same. The ratios are the same no matter how large or how small this triangle is. If theta remains the same, 30 degrees, 45 degrees, whatever it is, if theta is the same, I don't care how big you make this triangle, whether you make it tiny or huge, the ratio of the adjacent to the hypotenuse will always be the same. So these ratios have names, and they are our 6 trig functions. Sine of theta is always the opposite side over the hypotenuse. Opposite over hypotenuse. Always. Cosine of theta is adjacent over the hypotenuse. Tangent of theta is opposite over adjacent. Cosecant theta, abbreviated CSC, cosecant. Cosecant of theta is the flip of sine. Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. Oops. Hypotenuse over opposite. That was funny. Hypotenuse. Okay. Then we have secant. Secant of theta, abbreviated SEC. Secant of theta is the flip of cosine. Cosine is adjacent over hypotenuse. Secant is hypotenuse. Oh my gosh. Hypotenuse over adjacent. The flip of cosine. Cotangent is the flip of tangent. It's 1 over tangent. So it is adjacent over opposite. Okay? To help us remember these, we have SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. And also, it's crucial that you remember that cosecant, get that back lined up. Cosecant is 1 over sine. It is the flip of sine. 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent. Note that 1 over sine is not sine inverse. That is not true. 1 over sine is not sine inverse, okay? There's a button on your calculator. Sine inverse. Sine inverse is not 1 over sine. If you want cosecant in your calculator, you must type in 1 divided by sine. You cannot just do the sine inverse. Those are not the same. Okay, let's find the 6 trig ratios for angle theta. Here is angle theta up here, given this triangle on the right. Here's our triangle. There's our theta. The opposite side of theta is down here. That's opposite. Okay? We want to find the number for that. How do we find the number for that? Well, this is a right triangle, so it satisfies the Pythagorean theorem. And to find this side, I'm going to set up the Pythagorean theorem. So whatever this is, I'm going to call it x. X squared plus 2 squared is the hypotenuse squared. The sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So this tells me that x squared plus 4 is 9, so x squared is 5, so x is plus and minus square root of 5. Of course, this length cannot be negative, so this length is the positive square root of 5. Now, I would rather you not go through 4 steps to get that. Think to yourself, this length is the square root of the square of the hypotenuse minus the square of one of the legs, square root of 5. Okay? All right. Tangent of theta. Well, tangent is that is the TOA part of SOHCAHTOA. Opposite over adjacent. Opposite over adjacent. The opposite side is square root 5. The adjacent side is 2. Square root 5 over 2. Cosine. That's the CA part of SOHCAHTOA. That is adjacent over hypotenuse. So that is, the adjacent is 2, the hypotenuse is 3, so 2/3. Sine of theta. That is the SO part. So opposite over hypotenuse. Opposite is square root 5. Hypotenuse is 3. Okay. Secant. Secant is the flip of cosine. So we take 2/3, flip it. 3 over 2. Cosecant is the flip of sine. It's not really the flip, it's really the reciprocal. Reciprocal. Okay, reciprocal of cosine, reciprocal of sine. Okay, we had sine was square root of 5 over 3. This is going to be 3 over square root 5. We cannot leave an answer with a square root in the denominator, so I'm going to multiply top and bottom by square root 5. And that gets me 3 square root of 5 on top and 5 on the bottom. 3 square root 5 over 5. Cotangent theta. Cotangent is the flip of tangent. Tangent was square root 5 over 2. Cotangent will be 2 over square root 5. Again, when we rationalize that denominator, we're going to get 2 square root 5 over 5. Okay? It is convenient to remember, be familiar with some of our Pythagorean triples. There are a bunch of Pythagorean triples. We just need to know a few of them. It'll be convenient if you do. Otherwise, you're going to be using the Pythagorean theorem quite a bit. So, we have the 3, 4, 5 right triangle. We have the 5, 12, 13 right triangle. We have the 8, 15, 17 right triangle. and the 7, 24, 25 right triangle. It is convenient to be familiar with those. Okay? Of course, the largest number is always the hypotenuse. Of course. Right? Okay. Number 2. Let's find the 6 trig ratios for this angle theta given the triangle on the right. I see 8 and 17. I know that the Pythagorean triple that makes the 8 and 17 is a 15 down here. So 8, 15, 17, those are a Pythagorean triple. They form a right triangle. Okay? It's convenient to know that. Otherwise, you're going to be going over here and doing the Pythagorean theorem to get 15. Alrighty. Cosecant. Cosecant. Well, since I have to do sine anyway, I'm going to do sine first and then flip it to get cosecant. Sine is the so part of SOHCAHTOA. That is opposite over hypotenuse. Opposite. Here is your theta. Opposite is away from theta. So 8 over the hypotenuse. 8 over 17. So cosecant, 17 over 8. Cosine. Cosine is the ka part of SOHCAHTOA. That is the adjacent over the hypotenuse. Adjacent is 15. Hypotenuse, 17. What is the flip of cosine? Secant. Let's go do that. 17 over 15. Tangent. That is the toa part of SOHCAHTOA. So opposite over adjacent. Opposite is 8. Adjacent is 15. And cotangent is the flip of tangent. 15 over 8 then. These 6 are all of the different combinations, different ratios involving 8, 15, and 17. All of the different ratios possible. Okay, next up, we're going to get out our calculator and just get some, just put some of these into our calculator. So we're going to give the value of each correct to at least 5 digits after the decimal point. And this is in degrees, and these are in radians. So I have 2 in degrees and 4 in radians. So I'm going to go do the degrees first. So if we get our calculator, and how can I get this to where you can see it? How about that? Okay, I'm going to go to my mode, change it to degree mode. It defaults to radian mode, thank goodness. But change it to degrees. And then on our home screen, sine of 79 is 0.9816 at least 5 places. They said at least 5 digits after the decimal point. Note that, you guys, when you're putting in an angle like this, when you're putting this in, I'm trying to get this to where it's a little bit brighter. It's not very bright. When you're putting in the 79, the calculator does not make you close the parentheses. The TI-84 does not make you close the parentheses. You would get the same value whether you close it or not. So as long as it's the last thing that you're doing, you don't have to close that parentheses. Okay, while we're here, I'm going to come and get cotangent of 15 degrees before I have to go change it back to radian mode. Let's get cotangent. Cotangent. There is no cotangent button on the calculator. That is not cotangent. That is tangent inverse. Those are 2 different things. We don't want tangent inverse. We want the reciprocal of tangent. So cotangent of 15 degrees is 1 divided by tangent of 15 degrees. And that's what we need to put in our calculator. So 1 divided by, let me get to where you can see it, 1 divided by tangent of 15 degrees, 3.73205. Okay. The rest of these are in radians, so now we're going to go back and change it back to radian mode. So mode, radians. Okay. Cosine of 3 pi divided by 7 is 0.22252, at least 5 digits. Tangent of pi over 9. Whoops. Tangent of pi over 9. 0.36397. Okay. Cosecant of 5 pi over 6 is 1 divided by sine of 5 pi over 6. 1 divided by sine of 5 pi over 6 is exactly 2. How about that? Okay, secant of pi over 6 is 1 divided by cosine of pi over 6. 1 divided by cosine of pi over 6 is 1.15470. Okay, what if I know the value of sine and I want the angle? I want an angle whose sine is 2 over 3. This is where we need to use sine inverse. Think of it as, to get rid of sine, we sine inverse both sides. I'm going to sine inverse both sides. So theta will be sine inverse of 2/3. This is where we come and get that inverse button. Oh, goodness, get to where you can see it. All right, sine inverse, second sine, 2/3. Again, the calculator does not make us put that last parentheses in. 0.729. This time we have to give at least 3 digits. So theta is 0.729. Okay. Tangent of theta is 9 over 2. Therefore, theta is tangent inverse of 9 over 2. Tangent inverse of 9 over 2. 1.352. These are in radians. This is in radians. Okay. Cosine of theta is 0.3617, so theta is inverse cosine of 0.3617. Inverse cosine 0.3617. 1.200 radians. Okay. All right, secant theta. Well, just like there's no secant button on the calculator, there's also no secant inverse button on the calculator. If secant of theta is 5 over 3, then cosine of theta is 3 over 5. So theta is cosine inverse of 3 over 5. Right? So cosine inverse of 3 over 5 is 0.927. 0.927. Cotangent of theta is 3 over 8. Therefore, tangent of theta is 8 over 3. And theta is tangent inverse of 8 over 3. Inverse tangent of 8/3. 1.212. Cosecant of theta is 2.5, which is 5 halves, right? Therefore, sine of theta is 2 over 5. You could have left this sine of theta as 1 over 2.5 if you want to. Either one is fine. Okay? So theta is equal to inverse sine of 2/5. Inverse sine of 2/5. 0.411. Okay, so those are the 6 trig functions based on a right triangle.